Okay, so for our first exam, our first question, I will give you a function, and I will ask you to solve for x if f of x is equal to, let's say, 42. Okay? So what you do is you set 3x plus 6 equal to 42, and then you solve for x. So subtract 6 from both sides. 3x is equal to 36. Divide by 3. So x is 12. Okay, so we're going to have to solve this. This is negative 2. So don't forget if there's a negative out front. Actually, this should also be negative, sorry. If there's a negative out front, you have to distribute the negative in as well. So this is negative 2x, negative 8, right? Because negative 2 times 4 is negative 8. Minus 3 is equal to, distribute the negative 3, you get negative 3x minus 21. Okay, so I want to move all of my x's to one side, all of my numbers to the other, so I'm going to add 3x to both sides to get x's all to the left. So negative 2 plus 3 is 1x. These are like terms, so I'm going to combine that. And then I'm going to add 11 to both sides. So I get x is equal to negative 10. Type of problem, I'm going to ask you what property would you use first? And to simplify, okay, so what if I'm trying to simplify this? The first thing I need to do is what? Okay, this might look familiar, right? And whenever I have to distribute in a number, distribute the 3, I would use the distributive property first. Okay. If you're given an equation with multiple variables in it, and you're asked to solve for one variable, I want to get that variable by itself with everything else on the other side. So I want D by itself. Okay. So first thing I'm going to do is I'm going to flip this over so that D is on the left, just because it's prettier that way. And then if I want to get rid of EF, I subtract it from both sides. So I have 3D is equal to 6E minus EF. Okay, I'm almost there. I need to get that D by itself, so I'm going to divide both sides by 3. So D is equal to 6E minus EF divided by 3. Okay, if we're going to solve an inequality, you solve it the same way you would an equation. Add 5 to both sides. I get 6x is less than or equal to 30. Divide both sides by 6, and I'm going to get x is less than or equal to 5. The only thing that would be different, I'm just copying down, is if, let's say, the 6 was negative, and I divided both sides by a negative, then you flip that. Okay? So if you divide by a positive, you keep everything the same. If you divide by a negative or multiply by a negative, you flip the inequality. Okay, slope-intercept form is y equals mx plus b, because this is our slope, this is our intercept. So I want to make this look like that. So I want to move the x over, and if I move the x over to the other side of the equal, it was positive, now it's negative. And then I need the y by itself, so I'm going to divide everything by -4. Negative over a negative is a positive. So this is slope-intercept form. There are two ways we can do this. We can do this algebraically or graphically. Okay, so method 1 is graphically. So we're going to graph a line connecting the 2 points. So our first point is -3, -6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. And our next point is 2, 8. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Find your y-intercept. It's 2. Recording. Okay, so this may not be the exact point, because as you can see my line's a little off up here. And because I just made these numbers up off the top of my head, the y-intercept is probably not an integer. On your final, it is an integer, so as long as you draw a straight line, it'll work. Okay. Method 2 is algebraically, which is more exact. Alright, so first, we have to find the slope. So that's this equation, y2 minus y1 over x2 minus x1, which you'll recall. So if I do 8 minus -6 over 2 minus -3, yeah, see, I'm going to get 14 over 5. That stinks. Okay, number 2, we're going to use y equals mx plus b to find b. I'm going to pick 2 and 8, just because those are positive. Okay. So I put in my slope, I put in the x and the y, and I need to find b. So when you multiply a whole number times a fraction, if the denominator will divide into the whole number, you do that, but if not, you multiply the numerator times the whole number. And then I'm going to subtract 28/5 from both sides. Now, do that over here. 8 minus 28/5. In order to do this, I need 8 to have a denominator of 5. So I multiply 8 times 5 and I get 40. So I'm going to get 12/5, which is 2.4. So as you can see, we were close, right? And if it's given, if I'm giving you a multiple choice test, if you did a graph, you'd get close enough that you could say, oh, okay, well, my picture said 2. 2.4 is the closest one. So, okay, so I found my y-intercept, which is 4. I have my multiple choice answers. This is a positive 4, so I can eliminate the 2 that have a negative 4. Okay. My line travels downward as I move from left to right, so my slope is negative. So then I can look, if one of these is positive and the other one is negative, I could eliminate the negative, or the positive one. But they're both negative, so I can't do that. So now what I do is I move along the graph until I find another point that's perfect in the crosshairs, right? So to get from here to here, I go 1, 2, so I go 2 down, and then 1, 2, 3, 4, 5, 6, 7 over. Negative 2 over 7. So 2 down over 7. That's a 7. That's a negative 2. Because I go down 2 and then over 7. Okay, so here's how you figure this out. I take each of these points and I plug it into both of these inequalities. If it's true for both inequalities, it's part of the solution set. So I'll take A, which is 2, negative 3, and I'll plug that in, and I get 2 plus negative 3 is greater than 8, which means negative 1 is greater than 8. That's just for this part right here. This is not true, is it? So therefore, that's not a solution. I take 5 and 4. If I plug it into the first one, I get 5 plus 4 is greater than 8. That's 9 is greater than 8. This is true. And then if I plug it into the second one, I get 2 times 5 minus 4 is less than 7. So 10 minus 4 less than 7. That means 6 is less than 7. That is also true. Since it was true for both inequalities, it is true for the system. So basically, if we have a square box, so it's a cube, right? It's a very bad cube, but it's a cube. And to find the volume of a cube, it's length times width times height. So 2x to the third times 2x to the third times 2x to the third. So it would be 2x to the third to the third. Okay. So we need to simplify this. So we're going to simplify 2x to the third to the third. And in order to do that, I'm going to distribute the cubing in. So this is 2 to the third, and then I multiply my exponents here. So that's x to the 9th. And 2 to the third is 2 times 2 times 2, so that's 8x to the 9th. If you're asked to simplify this, you multiply like times like. When you multiply common bases with exponents, you actually add the exponents. So this is x to the 5 plus 2, so that's 7. Y to the 9 plus 3, so that's 12. And then z to the 2 plus 10, so that's also 12. So multiplying exponents, you add, multiplying bases, common bases, you add the exponent. If you take a power to a power, you multiply. And the difference is two x's, add the exponents. 1x, multiply. Okay, so we're going to FOIL this, or you can use the table. Myself some room. So FOIL, I'm going to multiply first, outside, inside, and last, which will give me 3x squared plus 2x minus 18x minus 12. So I'm going to combine my like terms. I get negative 16x. So this is my final answer. If you prefer the table, I get x plus 3x is 3x squared. 3x times negative 6 is negative 18x. 2 times x is 2x, and 2 times negative 6 is negative 12. And I combine the like terms on the diagonal to give me 3x squared minus 16x, and then negative 12. So, same answer, different process. Pick the one that appeals to you. In this next problem, these are containers. And this is the amount of water they can hold. And I want to know how much water can they hold in all. Okay. Well, if I want to know how much water a bunch of containers can hold in all, I'm going to add them up. So that's plus 2x plus 1 plus 3x minus 6 plus 4x plus 5, right? So this is the first container, second, third, fourth. And I'm just adding, so I have x plus 2x, which is 3x, plus 3 more x's, which is 6x, plus 4x is 10x. And I have 1 minus 6, which is negative 5, plus 5, which is 0. So all together, they can hold 10x worth of water. So to factor difference of squares, we take the square root of the first term, and we take the square root of the second term, and then we put those in parentheses with a plus and then a minus, or a minus and then a plus. That really doesn't matter, just so long as one of them's plus and one of them's minus. So this is not one of the polynomials that we can just factor easily. So what you would do first is you look for the largest number that we can factor out. So what number these all divide by? These will all divide by 5. Okay. And then I look at the variables. I have 1x here, 2 x's, and 3 x's. I can only take out the least amount. So here I can only take out a single x. I have 3 y's, 2 y's, and 4 y's. 2 is the smallest amount of y's. So 55 divided by 5 is 11. I took away the x, and I took away 2 of the y's, so there's 1 y left. 25 divided by 5 is 5. I took away 1 of the x's, so there's 1 left, and I took away 2 of the y's, so there are none left. And then 10 divided by 5 is 2. I took away 1 of the x's, so there are 2 x's left, and I took away 2 of the y's, so there are 2 y's left. Did that make sense? Like this, where you have a ratio or a rational expression with variables in it. In order to simplify it, first we have to factor. So step 1 is factor. Okay, this is a difference of squares, so that's going to be x plus 5 times x minus 5. Right, because the square root of 25 is 5. And then here, I can factor out an x. That's all I can do. So I have x times x plus 5. So our numerator was the difference of squares. Our denominator, I can factor out an x. Okay, and then I look for matching. X plus 5 and x plus 5 match. So I can cancel those. So that's step 2. And then I just write down what's ever left. Proportion with variables in it, remember we cross multiply? So I have 5 times x plus 5 is equal to 3 times 2x plus 1. Distribute that 5 and this 3. So I have 5x plus 25 is equal to 6x plus 3. Okay, so now we've got to solve this. So I'm going to subtract 5x from both sides, since the 6 is bigger. So I get 25 is equal to x plus 3. Subtract 3 from both sides, and I get 22 is equal to x. Okay, now remember, these have to match. Our radicands have to match in order to add them together. So we'll factor these. And I can pull out 2 2's, and that 3 gets left behind. So this will be 4 times 2 times 2. And here I have 3 x's. So if I divide it by 2, I have a remainder of 1. So I can pull out 1x and 1 gets left behind. So there's a 3x inside. So this is 16x times the square root of 3x. And I'm going to add that to 75 is 2 times 25, or sorry, 3 times 25, and 25 is 5 times 5. So I can pull out a 5. And 3 is already there. Same here, I can pull out an x from the x squared, and then there's going to be a 3 and an x left behind. So this is 15x times the square root of 3x. And then I add these two numbers, and I'll get 31x times the square root of 3x. If you recall, we can't have radicals in the denominator. So whenever we have a radical in the denominator, we're going to multiply so this is going to give me 2x times the square root of 5 times 20 is 100x squared over 20x squared. Okay. Square root of 100 is 10. Square root of x squared is x. So I'm going to end up with 20x squared over 20x squared, which in this case is just 1. That's kind of, I didn't mean to do that. But the steps are all the same. You may have simplification here where you end up with some other number or another fraction. In our case, though, it's simplified down to 1. We don't have to graph this to solve it. Okay. We want to know what the positive x-intercept is. X-intercepts are roots. And roots are factors. So what we can do is we can take this and we can factor it. Okay, because this is a -8, I'm looking for factors of -8 that will give me a difference of 2. So what can I multiply to make 8? I can multiply 1 and 8. They don't have a difference of 2. Or I can multiply 4 and 2. 4 and 2 do have a difference of 2. I want it to be negative, so I want my 4 to be negative and my 2 to be positive. Okay. Now, the x-intercept is the opposite sign of the factored form. Okay, so this is negative, this is positive, but in our x-intercepts are positive 4 and negative 2. So the positive x-intercept is 4. Okay, so we set equal to 0. That was our first step. Then we factor it. I can factor out a 3 and an x. And I'm left with x minus 5. Then I set each of these equal to 0. So x equals 0 or x equals 5.